Hey. Right? Hey guys, sorry. It says that audio was not, I don't know, something about audio. It always does this. Hey Maya. So we're gonna do let's do like an example from 1, 2, and 3 first. Those are just converting pressure units. Now these 1, 2, and 3 are not gonna be part oh, there's my cat. They're not gonna be part of your let's say like of the quiz, but 1, 2, and 3 you are going to have they're going to be like inside the example, and we'll do one of those too, how sometimes you have to convert pressure units. So let's look at 1, 2, and 3 first, okay? Let's see. I'm going to do number 1 where it says convert okay, I'm going to do number 1 where it says 99.35 ATM to millimeters of mercury, okay? Let's see. Let me make sure. Okay. Okay, can you guys see that? Let's see, 99.35, 2 millimeters of mercury. So the way we would do this one, let me make sure. Okay. This one, we would set it up like a proportion, just like we've done before. So we take what we have, which is 99.35 ATM. We're going to multiply it by a number so we can get the number in millimeters of mercury. So this is like unit conversions, exactly like unit conversions. So you would have to, basically you want to know what your final answer needs, what units it needs to be in, which is millimeters of mercury. So what you do want to get rid of is ATM, right? So ATM has to be at the bottom. Millimeters of mercury has to be at the top. Now, what numbers go here? This is where you use your cheat sheet. So if you guys remember the cheat sheet, do you guys have the cheat sheet? Make sure you have that out too. Let me just go to it right now. And if you look at your cheat sheet, it says Gaslat cheat sheet in the top section right there. I'm gonna see if I can show you guys. The one that says 1 ATM. Right here. So 1 ATM, what is it equal to? Millimeters of mercury wise, it's 760 millimeters of mercury. So it would be 1 ATM at the bottom, 760 millimeters of mercury. Okay? So you're converting the ATM to millimeters of mercury. So you get rid of ATM, you get rid of ATM. You're going to multiply 99.35 times 760, and then you're going to divide it by 1. So you're going to get 75,506 millimeters of mercury. Yeah, I'll go over those two combined Gaslat, Catalina. We're just going over the first part, but I will go through those as well. So that's how you would do the top ones, is just basically you look at the Gaslat cheat sheet, little the bottom part where it says what is ATM equal to regarding millimeters of mercury. You just multiply by the top, divide by the bottom. Okay. Questions on this one, on 1, 2, or 3? I mean, did you guys want me to do another one from 1, 2, and did you guys want me to do 2 or 3? Anybody need example 2 and 3 done, or does that make sense? Okay, number 2. Yeah, Maya, I can do number 2. Let me do number 2. Okay. So we go back to number 2. Okay, number 2 says convert 57 torr to millimeters of mercury. Okay, 57 torr to millimeters of mercury. Okay, so same thing here. You have to see what you start with. What you start with is 57 torr. Okay, you're going to multiply, and you want your final answer to be in millimeters of mercury. Okay, again. So you're going to go to your cheat sheet, guys. And remember, try to print out the cheat sheet or write it down in a piece of paper so you have it for the quiz. You're going to look for torr. So torr is 760, right? And millimeters of mercury is also 760. So because you want to get rid of torr has to be at the bottom. Millimeters of mercury has to be at the top. And both numbers are 760, right? Because 760 millimeters of mercury is equal to 760 torr. So if you think about it, it's 57 times 760 divided by 760, which means it's just going to be 57 millimeters of mercury. It's like a 1-to-1 ratio here. Because torr cancels out. 57 times 760, 760 divided by 760 is 1, so it would just be 57 millimeters of mercury. Okay, does that make sense? Does anybody need me to do number 3, or do you guys get 1, 2 with doing 1 and 2? That way we can move on to one of the other ones. Okay, good. Okay, so let's move on to, let's see. Let's do number 4. Number 4? Okay, let's do number 4. It says a gas is 70.98 liters at 118.2 Celsius. What volume would the gas be at 62.9 Celsius? So I'm just going to type up the problem here, guys, for you. So you guys, well, I mean, I bet you guys have it too. But I just want to make sure it liters at 118.2 Celsius. What volume would the gas be at 62.9 Celsius? Okay, so we're doing that one, number 4. Okay, so let's look at what we have. Let's write the numbers. I'm just gonna write the numbers here to kind of save time. 7.98 liters. Then we also have 118.2 Celsius. And then we also have 62.9 Celsius. Okay, so if you guys see, let's look at the variables that each one of these stands for before we decide what law are we using. So 70.98 liters. Liters, what variable does that represent? Do you girls know? What variable does liters represent? Yep. Nice job, girls. Volume. So 70.98 represents volume. And we know that's going to be our V1 automatically. Then 118.2 Celsius. What does 118.2 Celsius represent? So the Celsius ones, what do they represent? Temperature. Yep. So 118.2 represents temperature 1. And that means that 162.9 Celsius has to represent temperature 2. So if you look at your gas law cheat sheet, again, you're going back to that cheat sheet. Which law So which law talks about volume and temperature only? So what law are you using for this problem? Because you're using only volume and temperature. Which law only uses volume and temperature? What's the name of the law? Nice job, girls. Charles' law. So Charles' law is the law that we're using here. So that means that we are going to do V1 over T1 equals V2 over T2. Okay? But before we do that, you guys need to remember Celsius. You need to turn Celsius into Kelvin. Okay? We cannot use Celsius because Celsius is not a usable, it's not usable regarding these any of these laws, so we have to turn it into Kelvin. So that means we just add 273 to each temperature one. Okay? We add 273 to each one. So 118.2 118.2 plus 273 gives you 391.2. And then 62.9 plus 273 gives you 335.9. Okay? So you're using those numbers. So it's going to be V1, so 70.98 divided by T1, 391.2 is equal to V2, which we don't know, that's our X, over 335.9. So cross multiply, okay? So 70.98 times 335.9 gives you a big number. You're going to write the whole number down, okay? Don't round till the end. So you're going to write this whole number down. So that's 23,842.182. That's equal to 391.2x. Okay? And you want to get rid of x. I'm sorry, you want to leave x by itself, so you're going to divide 391.2 to both sides. Okay? All right, everybody with me still? We're going to do 23,842.182 divided by 391.2. Okay, everybody should get 60.94627301. Okay, but we need to figure out how many significant figures we're going to use. So how many sig figs does 70.98 have? How many significant figures do you guys see in 70.98? Yep, 4 sig figs. Nice, Evelyn. 4 sig figs. Good. Okay. How many significant figures? How many sig figs then do the temperature ones have? Both temperature ones have the same amount of sig figs. So temperature. How many temperatures do you get? How many sig figs for the temperatures? Yep, 4. So everything has 4. So that means that your final answer should have 4 sig figs. So you guys should have 60.95 liters as your final answer. Because the 6 makes the 4 round up. Throw it out. Why are you giving it to me? Really? No, it's not. Credos, stop it. All right. So do you guys get that one, that problem? Make sense? That's kind of how you're going to go with every single problem, guys. You're going to go through every single problem like that. This is what I suggest, is kind of identifying what variables I'm using. And so if we look, number 5, if you look at number 5, it's the same thing. It says a gas is 45 liters at 227 Kelvin. What volume would the gas be at 311 Kelvin? So again, we're using volume and temperature because 45 liters is volume, 227 is 227 Kelvin is temperature, so that's a volume and temperature, which is another one of these. Okay. All right. Let's do number 6. I think number 6 is not a. Yeah. Let's do number 6. Number 6. Okay. So number 6 reads: a gas is 68.9 liters at 37.40 ATM. What volume would the gas be at 66.10 ATM? Okay, we're gonna do that one. Okay. All right. Oh, I got a question. So when we're looking for a final answer, example volume, do we only look as the number of sig figs in the volume so that we know that many sig figs? No, you look at the whole thing, Maya, at volume, temperature, whatever other numbers are in there. So volume, temperature, pressure, whatever it is, you're looking at all of the numbers to see which one has the least amount of sig figs. So you're taking the whole sig figs into consideration of every single number. That's a good question, though. All the numbers, basically. Okay. So let's look at number 6. So it says a gas is, so we're going to do 68.9 liters. We have 68.9 liters. We also have 37.40 ATM. Okay. And then we have 66.10 ATM. Okay, girls. So let's see. 68.9 liters. What unit does 68.9 liters represent? $68.9 liters. What does liters represent? Yep, volume. Awesome. So 68.9 liters represents volume. So that's your V1. How about 37? How about 37.40 ATM? What does 37.40 ATM represent? 37.40 ATM. Pressure. Yep, pressure. Okay. ATM is for pressure. Kelvin and Celsius is for temperature, Maya. Yep, pressure 1. Okay. So this is our pressure 1. That means this has to be our pressure 2. So if you look at your cheat sheet, which of these works with which of these formulas works with volume and pressure? Okay, which of these laws works with volume and pressure? Boyle. Yep. So we're doing Boyle's law here. Okay. So we're going to look at Boyle's law, which is going to be volume 1 times pressure 1 equals volume 2 times pressure 2. All right. So 68.9 times 37.40 is going to give you 66.10 times X. Okay? So you're just going to multiply 68.9 times 37.40, and you're going to get 2,500 2,576.86 is equal to 66.10 times x. And then you're going to divide 66.10 to both sides. And you're going to end up with a big, big number, 38.984566, whatever, okay? So we need to figure out how many sig figs does the least number have, because that's how many sig figs we want in our final answer. 68.9, how many sig figs do you guys see there? 3, 3, 3, yep. This has 3 sig figs, and then 37.40 and 66.10 have the same number of sig figs. How many sig figs do both of these pressures have? How many sig figs do you see for those pressures? Pressures have a little bit more than 3. How many do you think the pressures have, guys? Remember, that's a trailing zeros. Trailing zeros count because there's a decimal. So yes, these are 4 sig figs each. So your final answer should have 4 sig figs. So you are looking at 38.98 liters as your final answer. $38.98 liters as your final answer. Okay, so we did Boyle's and we did Charles. All right, so we've done 2 out of all the laws. Let's see what else can we do. We want to make sure we get through all the laws so you guys have to kind of see what the laws are going to look like. So that was number 6. Number 7, I want you guys to notice number 7 is also a Boyle's law. I'm sorry, yeah, it was Boyle's, yep, Boyle's law as well, because it's liters, it's liters, which is volume, kPa, which is pressure. So don't forget, kPa is also a pressure unit. What I do want to do, though, is I want to do number 8. Number 8, okay? I want to show you guys why number 8 is a little challenging one. Doesn't mean it's impossible, but it is a challenge. A gas is 83.96 liters at 114.8 kPa. What volume would the gas be at 4.500 atm? That's number 8. I want you guys to notice that it's also a Boyle's law, okay? So let's look at number 8. So we have 83.69. Oh yeah, it's 83.69. Sorry, girls. 83.69 liters. 114.8 kPa. And 4.500 atm. What? What do you want? Sorry, my cat. What do you want? You want to go outside? Hold on. Give me 1 second, guys. Oh. What? Okay. So you guys notice liters, kPa, and atm. So why do you think this one would be difficult? What do you guys notice about number 8 that's different from the other ones that we've had? Does anybody notice something about number 8? This is number 8. These are the numbers from number 8. 83.69 liters, 114.8 kPa, 4.500 ATM. What do you guys notice about this one? Anything pops out? Yes, Evelyn Garcia, good job, girl. Both kPa and ATM are pressure units. If you remember from the notes, I say the units must always match. So if pressure is in kPa, pressure 1 is in kPa, pressure 2 needs to be in kPa. If pressure 1 is in ATM, pressure 2 needs to be in ATM. So the fact that the pressures don't match, this is why you did number 1, 2, and 3. Numbers 1, 2, and 3 was how do we convert pressure? Okay, so you have two options here. Two options. You can convert the ATM to kPa, and then that way both are kPa, or you can convert the kPa to ATM. So either option is fine. That's what I would do before I even start this problem, is you need to make sure the pressure units match. So kPa and ATM can't be different. Like the pressure units can't be different. They must be the same. So what we are going to do first is, I'm just for right now, I'm going to turn kPa to ATM. You guys can do whatever is best for you guys, but I'm just going to do kPa to ATM first. So it says 114.8 kPa. So what I would do is times is going to be equal to ATM. Oh, let me make sure you guys can see that. Let me just, okay. So I'm going to convert kPa into ATM, okay? So I want to get rid of kPa, that's going to be at the bottom, ATM is going to be at the top, and then I'm going to look at my cheat sheet to see what those numbers are that go with it. So give me 1 second. Okay, so kPa is 101.3, okay? So kPa is 101.3, and ATM is 1, okay? It's going to be 1 ATM over 101.3 kPa. Multiplied by the top, divide by the bottom. You can get rid of kPa now. So 114.8 times 1 divided by 101.3. You guys should get 1.133 and a big number like that. So just for this sake and purposes, we're going to keep it to 4 significant figures, since 114.8 kPa and 101.3 kPa are both 4. So I'm going to say it's 1.133, okay? For my, so we don't have to write the whole number, 1.133 ATM, okay? So instead of 114.8 kPa, now we're going to use 1.133 ATM. He's gonna. Okay, so instead of this number, now I'm using 1.133 ATM. Okay, now I just do the Boyle's law, just like I did it before, which is volume times pressure equals volume 2 times pressure. So it's going to be 83.96 multiplied by 1.133. That's going to be equal to 4.500 times X. Okay, so 83.96 times 1.133 divided, and then you're going to multiply that and you get 95.12668. Okay. And that's going to be equal to 4.500x. You're going to divide by 4.500. You're going to divide by 4.500. You guys should get 21.1392622. Okay. Yeah, it's 83.69. I'm sorry. I put 96 again. Oops. My bad, girls. Okay, I did that again. Hold on. Give me 1 second. Let's see. This number would be different. I'm sorry, Evelyn. I keep putting that. See, 83.69 times 1.133. It's 94.82077. Okay, and then the hold on. Okay, let's see. 83.69 times 1.133. Okay, 94.82077. And you're going to divide that by 4.500. And you should get 21.07. Okay? So 21.07, let's see, how many sig figs do we have? 83.69 has 4, this one has 4, and this one has 4. So we're going to leave it at 21.07 liters. Okay? Now, I want you guys to know that, let's say, for example, you switched ATM instead to KPA and you kept everything as KPA, you should still get the same answer. You should still get 21.07 no matter what unit of pressure you're using. If you're using ATM, if you're using KPA, it doesn't matter. You don't have to necessarily switch to the first one. You can switch it, whichever one you want, and you should still get the same answer. And I'm just gonna make sure you guys can see that. So I'm gonna just erase this real quick and say if I switch the other one so you guys can see. Okay, so if I switched ATM into KPA instead, it would be 4.500 ATM times, so it's ATM and then KPA, it's 101.3 over 1. So you would just multiply 4.500 times 101.3, and you would get 455.85. So instead of this number, you would get 455.85 KPA. And then if you do everything the same, okay, I'm just gonna do it a little bit quicker so you guys, we can move on. Times 114.8 divided by 455.85. And I got the same exact answer, 21.07. Okay, so you should get the same answer no matter what. If you choose to change ATM to KPA or KPA to ATM, I mean, it doesn't matter which one you do, you should still get the same answer. Okay? Okay, so let's keep going. All right. So we did number 8. Number 9, I think earlier, combined gas law. Okay, so Catalina, number 9 is, I think where you wanted to do, let's look at number 9, ladies. All right. Number 9 says a gas is, let me type this, a gas is 21.27 liters at 36.5 ATM and 121 K. What volume would the gas be at 22.2 ATM and 377 K? This is number 9. Number 9, okay? All right. So let's write down these numbers, okay? $36.5 ATM. $121K. Okay. Then we have 22.2 ATM. And 377K. Okay, so let's identify what each number variable wise stands for. So let's look at the first one, 21.27 liters. What does that stand for? What unit? What variable does that stand for? $21.27 liters. What variable does that stand for? Yep, volume, okay. So we have volume here. Okay. How about 36.5 ATM? What does that stand for? 36.5 ATM. What does that one stand for? Pressure. Yep. That stands for pressure, okay? All right. Now, how about 121K? 121K. What? Temperature. Yep, good job, Evelyn. Temperature. Okay. Okay, so we have volume, pressure, and temperature. And then ATM, again, that means we have pressure too. And then we have K again, that means temperature too. So if you look at you have to look at your cheat sheet. Volume, pressure, temperature. Then we have pressure and temperature again. So what law works with volume, pressure, and temperature? So all three of them. What law works with volume, pressure, and temperature? Yes. It's combined gas law. Now, I want to make sure you guys understand why it wouldn't be like ideal gas law, because ideal gas law works with numbers of moles, and this doesn't have any moles anywhere here. So combined gas law is the law that you're working with, okay? So key thing, I mean, just like number 8, you need to make sure everything matches, and everything does match because both pressures, pressure 1, pressure 2 are in ATM. Temperature 1, temperature 2 are in Kelvin. Perfectly. Volume, obviously, we only have one volume, so and it's in liters already, so that's perfect. So we're going to go ahead and get started on this one. So it's volume times pressure divided by temperature. So it's 21.27 times 121 divided by times 36.5 divided by 121 gives you 22.2 times x all over 377. Okay? So you're going to do this in your calculator. 21.27 times 36.5 divided by, 21.27 times 36.5, 776.355, okay? So I'm gonna write that down. Oh, sorry, I just multiplied these two. I just realized I also have to multiply times 377. So you're gonna multiply these three. Forget to multiply that other one too. Times 377. So it's gonna be 292,685.835, and that equals, you're going to do 22.2 times 121, and that's going to equal 268.6.2 x. Okay, and now you're going to solve for x. You're going to divide 2,686.2 to both sides. 6.2 to both sides. Okay, so if you look, it's 292,685.835 divided by 2,686.2. I got 108.959,063. So I want to look at all of these. How many sig figs do I have? I'm just going to do a quick overview for you guys. It looks like I have the least amount of sig figs is 3. Okay, the least amount of sig figs is 3 because 22.2 has 3, 377 has 3, 121 has 3. So we're going to round it up to 109 because 108.9 makes it round up to 109. So your final answer is 109 liters. And I just put it up here. Sorry, I put it up there. 109 liters is your final answer. And I think that's what I got as well. When I did this, oof, my bad. Mm-hmm. 109 liters. Is there any questions for this one? Any questions for this one? 109 liters. Okay, because I know this one's the toughest one. What I would do is I would multiply everything across first and everything across like this, just like you've done before. Cross, across, 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 across. Solve for x because that makes it like the process like 10 times shorter than trying to do multiply by the top and divide and do all, like it's just easier to multiply across, and then leave the division at the end. Okay? Catalina, does that make sense? I know you had questions about combined gas law. Hopefully this helped. Any questions on combined gas law, girls? So what I want you guys to notice is combined gas law is, no. Okay. Combined gas law, if you notice, numbers 9, number 10, number 11, number 12. Yeah, I want to do that one next. Number 13. Number 13 and number 14. Let's do an ideal gas law, but first let's do number 13 or 14. I don't care which one we do. Do you guys have a preference? Because I want you guys to notice. So all of 9, basically 9 through 14 are all combined gas law, but number 13 and 14 have that STP thing. They have STP, so I want to make sure you guys know how that's going to look like for you. Actually, let's do number 14, okay? Number 14 is actually a really good one, and then we'll go on to ideal gas law, and then that will wrap it up, okay? So it says a gas is 78.99 liters at 98.8 kPa and 252 Celsius. What volume would the gas, oops, I didn't spell volume right. What volume would the gas be at STP? Okay, number 14 looks something like that. Number 14, I want to make sure we get that one done, and then we'll do number 1 of the ideal gas law. Okay, so 14. Let's look at that one. So we have 78.99 liters, 98.8 kPa, 252 Celsius, and then we have STP. Okay, so 78.99 liters, 98.8 kPa, 252 Celsius. All right, and then what would be at STP? Do you guys remember what two numbers does STP represent? So standard temperature and pressure, that's what STP stands for. What is the standard temperature? Look at your cheat sheet. You have it in your cheat sheet. What is the standard temperature? What is your standard temperature? What is your standard temperature? 273 Kelvin. Yep. So your standard temperature is 273 Kelvin. Okay. So you have your first one of STP. Okay. Now, what is your standard pressure? What is your standard pressure? Does anybody know their standard pressure? It's also in your cheat sheet. 1.00 ATM. Nice job, girl. Okay. So as you can see, now you have two numbers as well. 1 ATM, 273 Kelvin. So again, I want you to notice both pressure and temperature. They have something unique about them. What is it that pressure and temperature? Look at both pressures that you have. Look at both temperatures that you have in this problem. What can you see about them? We can't just start the problem. Why can't we just go ahead and input the numbers and already start the problem? Why can't we do that? What do these numbers have that needs to be done first? Exactly. Different units. Different units means I can't do crap till every unit matches. So let's make these units match, guys. First of all, let's look at temperature. 252 Celsius. 252 Celsius. Kratos. Sorry. 252 Celsius. We need to add 273 to that. We can just simply add 273, and then that matches the Kelvin. So 252 plus 273 gives you 525. So your temperature is no longer 252, it's 525 Kelvin. Okay? 525 Kelvin. ATM, kPa, not the same units. I would switch, I'm going to tell you guys right now, for these kinds of problems, I would switch the ATM because you don't need to do any conversions for that. Really, you don't need to do much math to it. If you look, you already know in the Gas Law cheat sheet, you already know what one, let me zoom in. Can I zoom in? I can't zoom in. You already know that one ATM equals how many kPa? 101.3 kPa. So one ATM equals 101.3 kPa. So instead of one ATM, I'm going to use 101.3 kPa. Okay? So that way kPa matches 8 and units match. So I want you guys to understand, I didn't have to do any math because I already know that what one ATM equals regarding kPa. Just 101.3. Instead of switching the kPa, doing the math, changing it to ATM, it's just easier to do this, okay? So now I can put everything in there and input it, and I should get an answer. So do you want me to do this? But like now you guys know this is how you would set this one up, okay? I care more about the setup, and then, you know, obviously it's volume times pressure, so it's 78.99 times 98.8 divided by 525, that is equal to 101.3 times X over 273, okay? And that just becomes a simple combined gas law. Multiply top times 273, multiply 101.3 times 525, divide, find for X, least number of sig figs should be 3, and then that's it, okay? So this is as hard as it's going to get. Honestly, this is as hard as it's going to get. Combined gas law has the most numbers, so obviously it's the hardest law. It's also difficult when units are not matching, so you always have to put an eye out for that. Make sure your units are always matching, all right? So let's take a look at ideal gas law, and then we would wrap this up. Miss Nichols is also available now in her channel, guys. So if you still have more questions and you're like, I mean, I don't mind staying another couple minutes, but if you guys have more questions that I didn't answer right now, obviously go ahead and swing over there. But let's do number 15, okay? That's an ideal gas law. Number 15, okay? Does everybody see 15? 1-5. So that says what volume is 0.445 moles of gas at 399 Kelvin and 8.10 ATM. Okay? We're doing number 15. Okay, number 15. So we have 0.445 moles, 399 Kelvin, and 8.10 ATM. Okay. These are the only three numbers in this problem. So let's look, 0.445 moles. What variable does 0.445 moles represent, guys? What variable does that represent? N, yep. So this is N. Okay. How about 3.99K? What does 3.99K represent? Yep, T. Now, what does 8.10 ATM represent? Yep, 8.10 ATM represents pressure. So I want you guys to take a look at these three. So when you're looking at your gas law cheat sheet to see which one you're going to use, you have to notice that this is the only law that doesn't have like N1, N2, T1, T2, P1, P2. The reason why these don't have this is because ideal gas law compares at one instance. Like if you look at the question itself tells you what volume is the 0.445 moles of gas at 399 Kelvin and 8.10 ATM. If you notice, it's all at one instance. It's not asking what is the new volume, what is the updated volume, what is the different volume. You're looking at one instance, not at before and after. So your formula is PV equals nRT. So I want you guys to notice they're giving you P, they're giving you T, and they're giving you N. That means that right now you don't have R or you don't have V. Okay, you don't have R or V. However, R you can find. Okay, you can find R, but the R needs to match with the pressure units. So what pressure units are you using? As we can see, we're using ATM. So since we're using ATM, which R are we going to use? Okay, figure out which R we're going to use when you have ATM. Yep, you're using 0.0821. So your R okay. All right, that's your R. So now you can plug this all in and solve for V. So it's going to be pressure 8.10 times volume, which is going to be your X. Your N is 0.445 moles times your T, which is 399, times your R, which is 0.0821. Okay? Remember the numbers all on the right-hand side, the 0.445 times 399 times 0.0821. It doesn't matter what order you put them in because whatever you multiply them in the order, you'll still get the same answer. So it's 0.445 times 399 times 0.0821. So you're going to get 14.5772655. I'm just going to keep everything. I'm not going to round yet. I'm going to leave it like this in my calculator. And that equals 8.10x. You're going to divide both sides by 8.10. Okay? Divide both sides by 8.10. And you should get 1.799662407. Okay? So, how many sig figs? Again, the top one has 3, T has 3, P has 3, R has 3. So you want 3 sig figs at the end. So that means your final answer should be 1.80. 1.80 liters. Okay, 1.80 liters. And then that's it. So ideal gas law is a pretty easy law, not too hard. Because there's all units, like the only thing you're probably going to change if you need to change anything is going to be the temperature units by adding 273. But other than that, it should be pretty easy. I'm sorry, I know we went over a little bit. Are there any questions to any of these, guys? So we went through all the laws. The only one that wasn't in this worksheet is Avogadro's, but I won't put it in the quiz if it's not on this worksheet. This is how the quiz is going to look like. You guys are going to have 5 questions, similar as before, 5 questions. and you'll just have like explain your work maybe in one sentence the best way you can, or maybe explain your setup. Just if you explain your setup to me and then give me an answer. I don't want to make it multiple choice because sometimes the rounding of people is a little off, or sometimes they round in their calculator. I might give points for, even if it's a little off, I'm still might give points. I'll let you guys know. But yeah, so the quiz is going to look like just like all these problems that we did. The hardest that it's going to get is when you have to convert pressure units in the problem before you actually do the problem, okay? If you guys have more questions, please email me. If it's still you need like something like this, like one-on-one, I'll set up like a Zoom meeting thing in the weekend if it needs to be done in order for you guys to take the quiz. The quiz is on Monday, okay? Are there any more questions? If there's no more questions, girls, then I'm gonna get going. Hope you guys have a nice rest of your day. Again, like I said, email me, okay? Email me any questions. Don't, do the worksheet, try the worksheet, try the rest of the problems, look at the answer key, all right? Email me anything, any questions that you have, all right? Bye, guys.